Most users view a digital library as a simple destination, a high-capacity hard drive filled with PDFs and scanned documents. In reality, it is a highly engineered, interconnected data ecosystem. Digitizing 10,000 books and placing them on a server addresses the problem of storage, yet it leaves the challenge of discovery completely unsolved. Mass digitization produces a searchable pile, whereas a library requires a managed system. In information science, we define a digital library as a socio-technical system. It operates through integrated layers designed to categorize specific queries and facilitate precise knowledge retrieval. To see how these systems function, we have to strip one down to its foundation. We are going to build a digital library from first principles to examine each layer of its anatomy. Understanding this underlying architecture reveals the specific mechanisms that turn stagnant digital files into active knowledge. This infographic acts as our macro blueprint. The central illustration demonstrates the critical interplay between hardware, data pathways, and users. The system rests on three pillars. On the left, core components. On the right, strategic frameworks. And at the bottom, concrete models. Before applying high-level strategic frameworks, we must establish the ground floor. We need to construct the physical and digital core components that actually hold the data. Implementing a library model without these anatomical layers leads to systemic failure, resulting in broken links, creating unsearchable assets, and a useless archive. Our build begins at the foundation, information objects. These objects encompass a massive technological range. Modern libraries must ingest everything, from digitized manuscripts and ebooks to audio podcasts and educational simulations, and raw scientific datasets. This diversity creates an immediate bottleneck. A massive pile of unlabeled digital objects remains effectively unsearchable without a layer of intervention. We resolve this by applying the metadata layer. Metadata is data about data. It wraps every object in a shell of descriptors, housing the specific ontologies, taxonomies, and basic identifier tags that define what a file is and how it relates to its neighbors. This layer manages access rights and serves as the primary engine for all search and retrieval. When a user submits a query, they are communicating directly with this metadata architecture. Without robust metadata, a digital collection is merely a dark archive where information goes to die. With the data labeled, we install the technology infrastructure required to physically host it. This layer consists of secure, scalable storage systems and robust network conduits designed to handle high-volume data transfers and constant user traffic. Above the data stack, we place the user interface and services. The interface acts as a vital translator. It converts complex back-end metadata queries into intuitive, browsable pathways, allowing users to navigate through curated lists and faceted filters. Finally, we surround the structure with the human element, management. These systems require specialized roles to stay functional. Experts must curate content, specialists create metadata, and administrators resolve the technical issues that threaten long-term access. Technology provides the structural conduit, but specialized human intent ensures the ecosystem remains reliable and accurate. Building the core is only half the task. This framework from Rollins and Bodden illustrates how informational, systems, and social domains must overlap to create a functional service. To organize these interactions, we use the 5S framework, a roadmap for engineering the digital library experience. The base layer is S1, selection. Selection dictates the library's scope. Administrators must determine which objects are acquired and how they align with the institution's specific mission. Above that sits S2, structuring. This is the active application of metadata. Structuring creates the discoverable relationships and hierarchies that allow a user to understand how different pieces of information connect. S3 is sequencing. Sequencing determines the user's navigational experience. It dictates the order of search results and the paths a user takes to move from one resource to the next. These first three layers are the operational mechanics. They transform a raw selection of data into a navigable, structured environment. The fourth layer is S4, synthesis. This is where the library provides high-level value. Synthesis involves tools that enable users to compare resources, analyze disparate datasets, and generate entirely new academic insights. This reaches the peak, S5, or significance. Significance takes the macro view. It asks how the system impacts its users and whether it fulfills the broader ethical and societal goals it was built to achieve. A technically perfect database that lacks significance has failed its purpose. A true digital library must achieve a demonstrable societal or academic impact. An institution's target significance dictates exactly which architectural model it must adopt. Consider the federated model. This model links independent libraries together into a unified network, relying on strict protocols to create a single search portal for resources spread across multiple different organizations. The institutional repository takes a different approach. These are specialized, localized archives. They exist solely to collect and preserve the research outputs, such as articles and datasets, of a specific university or organization. National digital libraries represent the largest scale. These models focus on long-term preservation of national heritage. They handle massive volumes of historical records and government documentation, prioritizing cultural continuity. Finally, we see subject-specific and open access models. This logo for Shodh Ganga highlights its role as a reservoir specifically for Indian theses. These models provide deep curation for niche disciplines and work to democratize knowledge by removing paywalls and subscription barriers for researchers. There is no universal template for these systems. The ideal architecture is always a bespoke reflection of the institution's specific mission and user context. Choosing a model requires an analysis of pragmatic factors, beginning with the strict informational needs of the target audience. The volume and variety of the content will dictate the scale of the necessary technological infrastructure. Institutions must also navigate real-world constraints, long-term financial sustainability, recurring server costs, and the governance required for cross-institutional partnerships. From organizing raw data objects to applying theoretical frameworks like the 5S, each layer of the build is essential. A successful digital library is a deliberate engineering feat, a dynamic system designed to convert raw